Okay, so this is Graphing Quadratics Part 2, where we're going to do some examples of graphs. So I'm going to let you go ahead and try this one. Find the axis of symmetry first. Find the vertex using the axis of symmetry. You can find your y-intercept. You're not going to be able to find x-intercept, but you can get a y-intercept. And then I put this chart here to help you pick some points to graph it. So go ahead and take a minute to do that. Okay, so on this one, our A is 1, our B is 0, and our C is -3. So when we plug in for our axis of symmetry, we have 0 over 2 times 1, and 0 over anything we know is 0. So our axis of symmetry in this case is going to be 0. Okay, so now we plug in for our vertex. So our vertex happens to be, if I plug in 0, y equals 0 squared minus 3, which gives me y equals -3. Right? So our vertex happens to be the y-intercept. So since we can't use the y-intercept as another point, so y-intercept here, I'm going to write it in here, is 0, -3. Then we definitely have to find other points. So remember that when you're looking for other points, you're going to look for points on either side of the vertex. That's why I have here -2, -1, and then 1, 2. Right? So if I plug in a 1, I get y equals 1 squared. Oops, sorry. No. Okay, so 1 squared minus 3. So y equals 1 minus 3, and y equals -2. So there is my answer for 1, and it's also my answer for -1, because remember that it is symmetrical. Okay? Now we plug in a -2. Y equals, or a +2. 2 squared minus 3. So y equals 4 minus 3, which means y is 1. So when I plugged in a 2, I got 1, which means when I plug in a -2, I also get 1. So here are all of my points. Okay, I have my axis of symmetry. I can go ahead and draw my lines. There's my parabola. Oops, there's my parabola. I did forget to do these things. So my direction of opening is up. Since my A is positive, I do have a minimum because it's opening up, so I have a lowest point on the graph. And then don't forget your domain and range. Domain is always going to be -infinity to +infinity. And range is always going to be, since it's opening up, y is greater than or equal to my lowest y, which is my vertex y. And my vertex was 0, -3. So it is y is greater than or equal to -3. And in interval notation, it starts at -3 and continues to infinity. Okay, let's look at another example. So this one is interesting because this one actually does have x-intercepts. Though don't forget that you have to take out the -1 GCF in order to factor that. So why don't you go ahead and try this one. Again, find axis of symmetry first, plug it back in to find the vertex, and instead of using a chart for your nearby points, find those intercepts, x and y. Okay, list domain and range, minimum, maximum, direction of opening. Okay, so here my A is -1, B is 6, C is 5. So since my A is negative, my direction of opening is down, which means I will have a maximum. Okay, so let's find our axis of symmetry. -B, -6 over 2 times A, -1, which gives us -6 over -2. So my axis of symmetry is +3. So 1, 2, 3, I'm going to graph my axis of symmetry. And then I'm going to use that, I'm going to plug it back in to find the y of my vertex. So negative 3 squared. And the negative is on the outside, it's not in the parentheses, so I'm going to square before I attach that negative. Plus 6 times 3 minus 5. So y equals negative 9 plus 18 minus 5. Y equals 9 minus 5. So y equals 4. So our vertex is 3, 4. So let's go ahead and graph that. 1, 2, 3. 1, 2, 3, 4. Here's my vertex. Okay, so I can find my y-intercept by plugging in 0 for x. So my y-intercept equals 0 squared plus 0 minus 5, which gives me a negative 5. So my y-intercept is 0, negative 5. Alright, so I'm going to go ahead and graph that. 1, 2, 3, 4, 5 on the y-axis. I can mirror that. It's 1, 2, 3 away from my vertex, so 1, 2, 3 away. And then I'm going to find my x-intercepts by plugging in 0 for y. So 0 equals negative x squared plus 6x minus 5. I got to take out that negative 1 GCF. So I get x squared minus 6x plus 5. And now I can factor into my two parentheses. Signs are going to be minus minus. And the factors of 5 that add up to 6 are 5 and 1. Just to check, negative 5x, negative 1x give me negative 6x. Now I can put these both equal to 0. I don't need to worry about this negative 1 because there's no variable on it anyway. So x minus 5 equals 0. X minus 1 equals 0. So x equals 1. And x equals 5. So my two x-intercepts are 5, 0 and 1, 0. You always have to write it as an ordered pair. So we have 1, 0 here and 5, 0 here. And now I have 5 good points to graph this parabola. So much easier when you can find your intercepts. Alright, so my domain, don't forget, always negative infinity to positive infinity. And my range, it's opening down. So it's going to be y is less than or equal to the y of my vertex, which is 4. And if I write that as an interval, it's actually going to start at negative infinity because it's pointing down. And it's going to end at at positive 4. Okay. Why don't we look at one more example? Here you go. Take a second, work this out, and I'll put up the answer. Okay, so go ahead and check your answer. You see here that the axis symmetry is x equals 4. And then you plug it back in to find your vertex, which is here. It is opening up, so we'll have a minimum. You do have x-intercepts, 6, 0, 2, 0. You do have a y-intercept, but it doesn't fit on the graph. But since you had your x-intercepts, you don't really need it to graph it. And then you have your domain and your range.